Hello, welcome back. Let's go over this example problem for the disk and shell method of revolutions around different axes. So I have this example problem and the graph right here. Consider the function f of x equals the square root of x minus 1. So y equals the square root of x minus 1. We're going to focus on the limits from x from 1 to 5 and y from 0 to 2. So we're going to be looking at this area. So for part 1, part A, we're going to compute the results by the disk and shell method around the x-axis. So let's start off with the disk method. So for the disk method, let's get our equation here. So we have that the volume would be equal to, so this is disk method rotation about the x. Okay. Disk method rotation about the x, it would be pi times the integral of our limits a to b of our large radius minus our small radius squared dx. So again, we're looking at this shape where our cuts, it's also good to know we're rotating about the x, so our cuts are perpendicular. And we have them all the way until here. So we see that it's dx, so our limits are going to be x equals something. So plugging stuff in, we see that it would be pi times the integral of 1 to 5. So x would be 1 here, 5 over here. Our large radius would be this outer function, which is the square root of x minus 1 squared, minus our small radius, which is just this axis, this is the equation y equals, and this is the line y equals 0. So that might help you. Sometimes we have our dx with our x equals 1, our x equals 5, and the two functions in between are the y equals, and this is y equals 0. So this in class you probably see that there is no smaller radius needed, but it might be good to point out. If you're just starting off, you might not need that, but it might help you make sense. So I'm just going to rewrite simplified now. So I have x equals 1, x equals 5 for the square root of x minus 1, that quantity squared, minus 0 I don't need anymore, dx. Before I start integrating, let's even draw out a little more. Before I start integrating, can simplify my inside my integral here. 1 and 5, and the square root squared would just be x minus 1. So we have a pretty simple integral here. So my volume is going to be pi times the quantity, so my antiderivative here would be x squared over 2 minus x from 1 to 5. My volume is pi times that quantity. 5 times 5 is 25 over 2 minus 5. And let's just, minus 5 over 1 I'll even say. So this quantity minus the quantity of 1/2 minus 1. All that times pi. So just for writing all the steps out, pi. Then my quantity here would be 25 over 2 minus 10 over 2 minus the quantity of negative 1/2. Just to keep going here. Volume is pi. 25 minus 10 is 15 over 2. Minus a negative is plus 1/2. So that's going to be 16 over 2 pi, which is equal to 8 pi. That was the disk method. Now I want to do the shell method and show that it's the same. So now show the shell method is the same. So our shell method equation, the best way that I'm going to show it, I guess, volume is equal to 2 pi, the integral from c to d. I have my radius, which would be r, times my height, my function, g of y, 2 pi rh, and then dy. So now that I have dy, my limits are in y equals. It's just good to know if we didn't know that already. Okay. So let's start tackling our question here. I want to bring our graph down again so that we can start finding the limits. So let's steal this. Simple graph, I could draw it out too, but to make it as neat as possible. Boom, let's have this here. Move it over. Okay, cool. So I need to know, I'm still rotating about the x. My shell method, my cuts are parallel to the axis that we're rotating around. So that means I need to make sure I have my limit here of my x equals 5 line. And again, these are our two lines. So this is an x equals equation and an x equals. We just know these are x equals equations. So what would my limits in y equals be? We see that it would go from y equals 0 to y equals 2. I like having that written there so there's no confusion. And my 2 pi on my outside still, I multiply it in the end. So I have my y times, and if we see here, we need to know that my cuts go all the way until 5. So I need to write 5 minus my other equation that I need it to be an x equals. So right now I have that y is equal to the square root of x minus 1. Just quickly do that. Y squared equals x minus 1. Y squared plus 1 would be equal to x. So this is my, so again, this is my two different equations. My 5 minus my y squared plus 1 dy. Why do I have that? Well, if I need to see what my length is, so for example, if I said is x, just to test, if x equals 1, okay? If x equals 1, and I was to jump into this equation, how long would my length need to be? I'm sorry. If y equals 1, now, if y equals to 0, which is when x equals to 1, how large is my cut? It would be 5. It would be 5 minus 4. 5 minus y squared plus 1, which means y is 0, would be 5 minus 1, which is equal to 4. And we see that that length that we want to slice is indeed 4. So that's how we can kind of double check this. So that's the length of my cut there. So now now that I can sort of verify that's right, we can start simplifying and then doing our math here. So 2 pi, integral from 0 to 2. So I'm going to distribute later. Let's simplify the inside first. 5. So it would be 5 minus 1, so we can jump right to 4, minus y squared dy. Volume equals 2 pi, 0 to 2. So I'm going to have negative y to the third plus 4y dy. Moving it on, Let's get our antiderivative here. Y to the 4th over 4 plus, just keep the 4, y squared over 2. We can see 2's cancel out. We have a 2 here. And we're going to go from 0 to 2. Volume is equal to 2 pi times my quantity, negative 2 to the 4th over 4 plus 2 squared. 2 times 2 squared, which would be 2 to the 3rd, but a little bit simple math there, so that's okay. My volume, 2 pi. So 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16, negative 16 over 4, plus 2 to the 3rd, which is 8. So I'm going to still have my 2 pi here. Negative 16 over 4 is negative 4, plus 8 is equal to, on the inside we have positive 4 times 2 pi is indeed 8 pi. We show the volumes are the same. So in the next video, we will go over part B, rotation around the y-axis.